Science is real, from the Big Bang to DNA. Science is real.
In the REAL 2 experiment, you will make spectrophotometric measurements. You may also have the opportunity to characterize your soil by using different techniques. Your primary task will be to filter the contaminated samples and then test these using the flame atomic absorption spectrophotometer. You will also be involved with data analysis. You will also have the opportunity to complete tasks described in the REAL 3 experiment. In this experiment, you will make use of spectroscopy, which is the interaction of light and matter. As you've learned previously, light may be described as having either wave characteristics or characteristics of a particle. Spectrophotometry refers to analytical techniques that use light to measure chemical concentrations. You applied spectrophotometry in an earlier investigation involving kinetics. When light or electromagnetic radiation interacts with matter, the energy may be absorbed. Some spectrophotometric measurements involve the absorption of radiation. Others are interested in the emission of radiation. The flame atomic absorption spectrophotometer is used to measure the absorbance of light. The actual instrument is shown here. On the left side of the instrument is the light source, which is called a hollow cathode lamp that is specific to the elements that are being tested. On the right side of the instrument is a detector that is set to the correct wavelength for the element being tested. In between the light source and the detector is where the sample is found. With flame AA, a cuvette is not used to hold the sample. Instead, the sample is introduced into a flame. Notice how the color of the flame changes. This is very similar to the flame test that you may have performed in an earlier lab. Moving on to your actual samples. Remember, in REAL 1, you first contaminated your samples. They must now be filtered. To help you accomplish this, 6 clean vials will be provided. You may choose to directly filter your sample into the clean vials. At the end of this laboratory session, you will be asked to clean and return the plastic bottles. This is easily accomplished by using the solvent of your choice and your favorite abrasive implement. Voila! Clean plastic bottles. When using the flame AA, you'll be directed to the instrument. It will either be in 150 Celeste or 2045 McPherson. You should bring the appropriate calibration solutions, your filtered soil solutions, your laboratory notebook, and something to write with. Someone will be on hand to assist you with the flame AA. They will make sure that the flame is on, the correct lamp is selected, and that a blank, which is pure water, is first tested. The absorbance is set to 0 for that sample. Your samples are then introduced, testing first the calibration standards and then the soil samples. With this information, you can begin the data analysis. You have made calibration curves in earlier labs. In this case, the x-axis is the metal concentration, expressed in parts per million. The y-axis is the absorbance read from the instrument. You should expect the absorbance to increase as the concentration of the metal increases, and then reach a plateau. Your calibration data will be evaluated and also graded. Once again, you should not expect your flame AA data to be described by a linear fit. Adding a simple line misses much of the data set. However, using a line between two adjacent points should be okay. Bringing a computer to lab so that you can accomplish this analysis within the lab period is a great idea. A data table is provided to help with your analysis. Please try to complete this table while still within the lab. Not everyone can use the Flame AA at the same time. For this reason, we ask that you be patient. There are also other tasks available that you can begin working on. One of these tasks is to use the X-ray fluorescence spectrometer. X-rays are more energetic than photons of visible light, and their emission will be measured with this instrument. With the XRF, high-energy X-rays are first used to remove core electrons. When relaxation occurs, these vacancies are then filled by electrons moving from higher to lower energy levels. Secondary X-rays are emitted in this process. These are measured by the instrument. Our instrument cannot detect elements lighter than calcium. For this reason, a plastic bag is invisible to the instrument. The XRF is a portable instrument that will be brought to the second or third floor of Celeste Lab. You will simply place your sample in a plastic bag, put it into the chamber, and close the lid. The XRF has many advantages. It is rapid, providing data in just seconds. It does not require a calibration curve. It can provide compositional data at either the percentage or ppm level all at the same time, and it does not destroy the sample. The instrument is amazing and will certainly be used by scientists far into the distant future. You are asked to record and compare your results for your samples with those of your classmates. You will also have the opportunity to quantify the soil organic matter for your samples. This is accomplished by adding the chelating agent EDTA. The chelating agent will bind to metal cations. This will displace the organic matter and make it free in the solution. The actual test involves taking 1/2 gram of soil and placing it in a beaker. Sodium hydroxide and EDTA disodium salt will be combined, and the entire sample shaken or stirred for about 30 seconds. After filtration, you can compare the color intensity of the filtrate with that of known standard samples containing 1 to 4% soil organic matter. Please use the information in this video to make a plan for lab. Your TA or peer mentors will be on hand to answer questions.
You know that it would be untrue. You know that I would be a liar if I was to say to you, girl, we couldn't get much higher. Come on, baby, light my fire. Come on, baby, light my fire. Try to set the night on fire. The time to hesitate is through. No time to wallow in the mire. Try now, we can only lose, and our love become a funeral pyre.